Welcome back to another STEM with Miss Dubois video. In today's video, we are answering what is a lever? A rod that rotates around one point. That one point is known as the fulcrum, and the fulcrum does not move. The purpose of levers is primarily to lift things, like that's its biggest function. But there are levers that cut things or open things. And even when we think about opening things, like a lever opening things, it's technically lifting that thing up just by creating an opening between whatever that object was on and the object itself. A lever's primary function is to mostly lift things, though, and I really want to emphasize that. And there are three types or classes of levers. There is a first class lever where the fulcrum is in between the load and the effort. The effort is the force that you are applying, and the load is always the object being moved. So think of it like this, because I've mentioned these words quite a bit throughout this video. The load is the object that you're moving, always, because you're loading it on to the simple machine. The effort is the force that you, the person, are putting onto the simple machine. Think of effort as you are putting it in, so you are giving it effort, or you are using effort. Think of load as you are loading it on, like you are piling it on. Now that we have that out the way, in a first class lever, you can see the fulcrum in the middle, and examples of first class levers include seesaws and crowbars. The second class lever is where the load is in between the fulcrum and the effort. So where you pile the stuff on, where you put the machine on, that load is in the middle, and the effort is on the end, and the fulcrum is on the way other end. Examples of second class levers include a stapler and a wheelbarrow. A third class lever is where the effort is between the fulcrum and the load. And as you can see, the fulcrum is on the end and the effort is in the middle this time around. All right, so let's look at it like this, okay? The fulcrum is the point that the rod turns around, like pivots around basically. The load is the thing that you are trying to move, the whatever it is, right? It could be a baseball. Effort is the work that you are putting in. You are giving that effort. So the effort for a third class lever is in the middle because you are kind of, or whatever force is being applied is going to be in the middle of the fulcrum, the thing that the rod pivots around, and the load, the thing that you want to move, the object that you want to move. You're not moving it yourself, or else you wouldn't be using a simple machine. Does that make sense? I hope it does. Let me know in the comments. Examples of third class levers include tweezers and baseball bats, with the elbows being the fulcrum, the effort being the hands, because that is where you are inputting your force, and the load being the baseball. The reason why elbows are the fulcrum this time around instead of like the effort is because you're using your elbows to rotate when you swing a baseball bat. You're not actually gaining a lot of force from that. It comes mostly from the lower part of your arm and where your hands are. So naturally that is below your elbows. That is why it is the effort. And the load is the baseball, because when you swing a baseball bat, you ideally want to hit a baseball very far. I hope that makes sense. So now let's calculate the mechanical advantage of a lever. The ideal mechanical advantage is the effort arm divided by the load's arm. This means that the effort arm is the distance between the fulcrum and the effort, and the load's arm is the distance between the load and the fulcrum. The actual mechanical advantage of a lever is load's force divided by effort's force. We've seen this so far with every one of our simple machines. But in levers, the load's force is the weight or resistance being lifted, and the effort's force is the force that you apply. And that was today's video where we answered what is a lever. I'm STEM with Miss Dubois. Thanks for watching. I hope you have a great day and a great life. Bye!